Hi, this is Stuart, and in this video I'm going to walk you through the output variable of Protosc, and I'll show you how to generate methods and results texts, as well as a feature table based on your outputs. So I already ran the analysis. I used the auto-generated script for that from the last video. And this is the output struct that I got. So first, let me show you um, the figure that goes with it. So if you want to reproduce that, use Protosc all figures. Oh, it overwrites the open figures. Where is it? Here it is. So we already went through this one. So here we see the chi-squares values, the cumulative chi-square values, the performances, and the significant features. So let's have a closer look at what features these are. So there's a lot of information in the output variable. And what I did is I made a subfield called main findings just to make it a little bit easier. So most of the information that you see here is represented over here, the relevant stuff. So here we have the filter performance, which is this one, and its probability based on a permutation test. Then for the wrapper, this one, random selection, pseudo-random selection. So here are the main performances. And even though none of these are significant, we do find significant features, which is simply because there's a different procedure behind it. So Protosc can make a different selection of features every time. So these reflect how well a particular procedure resulted in decoding the categories, but these look over all different methods and find features that are consistently associated with above chance performance. And we do actually find significant features here. And there are these ones. So the main feature is has an index of 229. So where is that in our reference frame? So let's have a look at that. So you can use Protosc find features for that. You give out, because, and I'll show you that in a minute, that's where your reference frame is stored, and you give the number of the feature that you're interested in. And here we see that it's along the diagonal, and it's a relatively high spatial frequency. Okay, so like I said, the reference frame is in out as well, and it's stored in settings. So all of the settings that you used while running the analysis are stored so that you don't have to remember them. And here's the reference map. So if you want to get to the reference map, you can get there as such. A particularly interesting one, noteworthy one, is the updated file list. Sometimes images don't load, but this is then the file list that you used, the variable that you use, is actually incorrect. It doesn't represent the images that you used, but this one is all the images that did succeed in loading. So these are all the settings for your analysis. Out point all data contains what you put into the feature selection algorithm as input. So it's all the features and all the examples, all the features. The first column is labels. That's why it's 385 instead of 384. And I'm using free color channels. So that's why it's a free here. Like I said, all settings. There's some info on the code. So just which scripts you used and what directory and when. some info on the data, but that's also in other variables. So this is a little bit redundant. So let's have a look at the big one. So there's usually not much to do here, because most of this stuff is just used by Protosc to create figures and just to keep track of everything that it's been doing. So one that might be interesting would be, for example, to see the specific results of each fold of the wrapper. So here we can see all the accuracies. So this might be relevant if you say, well, I want to calculate the standard deviation. On the other hand, and that's what I'm about to get into, you don't need to do it that way, because you can also just have Protosc write all the relevant stuff for you. So you can write feature tables, methods, results. So let's look at this one first. It's already open. So this is an example of the results as written by the function Protosc report results. So it shows you how many features were associated with performance above chance, what the associated p-values are, and how each of the 4 approaches are doing separately. So they were corrected for multiple comparisons and set their criterion at 0.01. And per approach, so here's the filter selection approach, it shows you a p-value, and it shows you the mean and the standard deviation. And we do that for all of them. So there are some combinations of results that lead to actually a bit more extensive input that will help you with your interpretation of the results. Another one that might be nice is to report your settings. So Protosc report methods also gives an automatically generated text file, and that's this one here. So this was an analysis based only on Fourier features. So there's only there's a short few words on feature extraction, how many images, how many categories, and then it explains the settings for the Fourier magnitude. So here we used, for example, 24 equally sized spatial frequency bands, 16 orientation bands, 384 features. Downside, the size of the features, images is mentioned. And then it describes the basic settings of the machine learning approach. So for example, if you change to 8-fold, then this changes to an 8. Things like that. Finally, if you want to use these results that you get from the feature selection procedure as covariates, for example, you can use report feature table to create something like this. So here we see in column A, it notes all the full file names of the images that were used in the analysis. And then, per significant feature, it indicates what the value of that given feature was. Now, you may notice that I have here feature 283.1, 0.2, and 0.3. So why is that? Well, that's because we used a linked analysis for RGB images. So these are the values reflecting the R channel. These are reflecting the B channel, and these are reflecting the the G channel, and this is the B channel. Finally, although we don't pay much attention to it, if you are interested in the full model, so one without feature selection, the results are over here. So it gives the F1 scores and the accuracy per fold, as well as the predicted labels per fold. Everything is stored, but I think this would be the main one to be interested in. Some other information that is also recorded in the results output. So when you automatically write results section, are the max model params and the search space sizes. So the max model params indicates how many features were allowed in all the models per fold, and the search space size is for the wrapper, and it indicates how big the search space size was for each of the folds. So over how many features it tries to find a relevant addition to the model at each iteration of building the wrapper model. So those might be interesting to have a look at. Okay, that's it.